Okay, so I'm doing the Danish FP9 Folkeskolens Afgangsprøve from May 2019 in maths, and I'm looking at the longer 3-hour paper. That's the one where you're allowed to have reference books and calculator. So I'm looking at question 2, which is called cycle trip. So I'm just going to go to my white paper and put the heading for that. So here's my white paper. I'll put question 2 heading over there. Cycle 2. Get my nice ruler to underline that. There we are. And we're good to go. So over to the question paper. And here's question 2. Anna and August have decided to cycle the 82.8 kilometers to the camping site. According to an app on Anna's mobile phone, the cycle trip will take 3 hours and 50 minutes. Anna and August would like to be at the campsite at 1300 hours, 1 o'clock in the afternoon. Question 1, what time do Anna and August cycle from home if they're planning according to the app? So if they're making their plans according to the app and would like to be at the campsite at 1 o'clock in the afternoon, 1300 hours. So it's basically asking you what is the time that is 3 hours and 50 minutes before 1300 hours. So on my yellow paper, I'm just going to go, so the hours, minutes, so you've got the time they want to be there, 1300 minus the 350 it takes. So how you do this, you can't do 0 minutes minus 50 minutes. So you could go into the whole borrowing minutes things, but then you've got to remember that there are 60 minutes in an hour, not 100. So that could cause confusion. Yeah, so the answer isn't 9 hours and 50 minutes, because that would be if there were 100 minutes in an hour. Good way to do this is to convert the problem by saying that 13 hours and 0 minutes is the same as 12 hours and 60 minutes. So turn one of the hours into 60 minutes, and then you can do 12 hours and 60 minutes minus 350. And then it works as a subtraction, with everything on the top being bigger than everything on the bottom. So 60 minus 50 is 10 minutes. 12 minus 3 is 9 hours. And 9:10 is the time that they need to leave. So let's just think of how I'm going to set this out on the neat paper. So I'll go 2.1, time they need to leave, till colon there, calculation over here. So I'm essentially doing 1310, is that right? no, 1300 minus 350 hours to minutes equals, what time was it? 9:10. So I'll have space here for the units. So I'm going to put 10 minutes there in the boxes. Let's make that small m. Small m. I'm going to zoom in on that. So 10 minutes. And I'll make that the column where my decimal point goes in the future. 9. There we go. And I'll just leave some space there for future answers. So I want the tens, the hundreds, the thousands there. So I'm going to put my equals column here. In fact, I'll put it here. I'm just thinking about how I'm going to line up the answers down the rest of the page, because all down the whole page I want my equal signs to line up, I want my decimal point to line up, I want these colons to line up, and I want the description of the answer to line up. And then finally I'll underline my answer. See if I can get a double underline. There we go. And then I'm setting it out in the format required by the exam, which is to have a description down there, a single expression that leads to the calculation of the answer, equals, answer down here, lined up at the decimals. They do like that good order in the exam. Okay, so on to question 2.2. Let's have a look at question 2.2. What does Anna and August's average speed have to be if they are to cycle the trip in 3 hours and 50 minutes? Okay, so it's 82.8 kilometers, and they've got to cycle it in 3 hours and 50 minutes. So onto my yellow paper again. And 82.8 kilometers in 3 hours and 50 minutes. And well, it would be a good idea to convert the 3 hours and 50 minutes into a single unit. And we want the average speed in, well, I guess we want it in kilometers per hour really. But I'm not going to try and convert 3 hours and 50 minutes into just hours just yet, because I've got the problem that there aren't 50 minutes in an hour. So it's going to be easier to work with if I just convert it into minutes at the moment. So that's 82.8 kilometers in 230 minutes. 230 is 3 times 60, which is 180, plus 50 minutes. Okay, if they can go 82.8 kilometers in 230 minutes, then in 1 minute they can go 82.8 divided by 230. So 82.8 kilometers divided by 230 in 1 minute, and then in 1 hour they can go 60 times as much, because they've got 60 times as much time to do it in. So 60 times 82.8 divided by 230 kilometers is what they can do in 1 hour. So over to the calculator. Just get rid of all the stuff I had there from the previous question. So I'm making a fraction with, let's have a look, 60 times 82.8. 60 times 82.8. Oh, that should be on the top of the fraction. Oops. There we go. 60 times 82.8 divided by 230. 21.6. Okay, so their average speed is 21.6 kilometers per hour, because that's what they can do in 1 hour. So I don't want lines and lines of working like that. What I want is the single calculation that leads to 21.6, where you can see where all the numbers came from. So if I take that, you can see where 60 comes from, because 60 minutes in 1 hour. 82.8 was in the question. It's not obvious where the 230 came from, and I got the 230 from 180 plus 50, which was 3 times 60 plus 50. So I'm going to rewrite that fraction as 60 times 82.8 divided by 3 times 60 plus 50. And now everything in that calculation is something that came from the original information in the question. So over to my white paper. I'm just going to actually sneakily copy this guy here and paste it into my white paper. If it'll let me do that. There we are. So that's going to go over there where we want the calculation. And so the question was asking for the average speed, Genomsnittsfahrt. So I'll just write the word average speed. I'm going to struggle to fit that in, actually. So I'm going to use the magic of the iPad to cheat a bit and go write it down there and then just resize it. Of course, you don't have this luxury doing it by hand, but it's also easier by hand, just to kind of do this without a lot of other messing about. Okay, so average speed is that expression in kilometers per hour, which is equal to, what did I say it was? 21.6. So I'm going to try and keep my equal signs lined up and my decimals lined up and my units lined up. Try and make that neater. Kilometers per hour. In fact, looking at this, I could probably just move these guys over a bit and move those columns, those colons over a bit, and then stretch that guy out a little bit and make it a bit more readable. So I'm sort of obsessing over the presentation here just to kind of give an idea of what the gold standard is for setting things out. Underlining my answer. Oh, what's happened there? Get rid of that. There we go. Oh, on to question 2.3. That's a lot of messing about with getting things tidy, isn't it? 2.3. After the cycle trip, Anna can see the graph below. Anna can see the graph below on her mobile phone. The graph shows the relationship between the time she's been cycling and her speed. Okay, so her speed goes up and down during the journey. Looks like she reaches a top speed of 60. She takes several breaks. So there's a break there where her speed's 0. 1, 2, 3, 4, 5, 6, 7, 8. That's not quite a break. 9. At least nine breaks. And overall, her speed's usually between about 20 and 40. Maybe 10 and 40. And the question says, describe in a short text what the graph shows about Anna and August's cycle trip. In the text, you've got to involve the time, speed, and pauses, breaks. Okay, well, I could say that the journey took 3:28 as well. So I think there's at least 4 things I could say about that. I can talk about the fastest speed, the breaks, 1, 2, 3, 4, 5, 6, 7, 8, at least 9, plus a couple of points where she slows down. And the fact that most of the time she was in that middle block. Okay, so let's just try and do that in my bad Danish. So I'm going to write description. So the trip took 3:28 and 20 seconds. Okay, so I'm going to write under here. Cykelturen tog 3 timer 28:20. order to a minuta or 2 seconda. So this is kind of free prose, free text. So I'm not kind of going to bother with trying to line up answers down there because it's just a text description. In fact, I think what I'll do is make these bullet points. So I'll kind of shift them over there and stick in some bullets there. That's kind of easy to follow, I hope. So what else can I say? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 breaks. Det var minst 9 pauser des var 0 km timer. There were at least 9 breaks when their speed was 0 kilometers per hour. Next bullet point. Their fastest speed was 60 kilometers per hour. Hurtigste fart var 60 km/time. And finally, their speed was usually between 10 and 40 kilometers. Des fart play. How do I put playa adver in the past tense? Playa adver melum. What did I say? 10 and 40. T km/time or for km/time. Okay, so their speed was usually between 10 kilometers an hour and 40 kilometers an hour. If I have made a glitch in the Danish, do write it in the comments. I won't read the comments. Let's just move that guy. Down there. So I'm not clashing into my answers column down there. Okay, well, I'm not going to bust any more of a gut for that. I think I've done a fair amount to get some marks there. I think I'll just underline that one there and go on to question part 4. So I'll put 2.4 there and have a look at the next one. Oh, I do hate this thing that keeps popping up, but there we go. Oh, I'm on to the last bit. Give a suggestion for how a graph that shows the relationship between time and distance for the parents. Oh, I haven't read the bit at the start. Anna and August's parents drive the same trip on an electric bike. Therefore, they drive with a more constant speed of around 20 kilometers an hour. After the trip, they tell that they've used 5 hours and 20 minutes on the trip, and they've taken 2 pauses, 2 breaks on the way. Give a suggestion for how a graph that shows the relationship between time and speed for the parents' cycle trip could look. And then you can use the SVA-arc, which is the supplementary sheet that they've provided, which is, I've got it at the back here, there it is. So it's a supplementary sheet for question 2, and it's got time and speed. Okay, so let's just undo that I did there. So back to this question. Well, first of all, on my main white paper, all I'm going to do here is write so graph has the thing describing it. Just going to get my colon in the same column as before. And all I'm going to write is C SVA-arc. And then the person looking at this is going to know that my response to this question is on that supplementary sheet. So that's my white paper done with for this question. So let's just have a look at the question paper again and get our head around this information. So they've used 5 hours and 20 minutes on the journey. Their average speed is 20 kilometers per hour, and we know that the journey is 82.8 kilometers. Okay, so 82.8 kilometers, 20 kilometers per hour. The journey is going to take 5 hours and 20 minutes, and they're going to take 2 breaks. So I'm just going to borrow that information, go over to my graph, just going to paste that guy. Okay, so we've got the key information, 82.8 kilometers and 20 kilometers per hour. So if they're going at 20 kilometers per hour, it's not going to take them the whole 5 hours, 20 minutes. And they're going to take 2 breaks. But at the consistent speed of 20 kilometers per hour, how much time will they spend cycling if they're going to go 82.8 kilometers? So I think I'll go onto my yellow paper there. So 20 kilometers in 1 hour. So 1 kilometer would take 1/20th of an hour, and 82.8 kilometers would take 82.8 20ths of an hour. And 82.8 divided by 20, if I get onto my calculator, is 82, I'll clear all that, 82.8 divided by 20, 4.14. 4.14 hours, and 0.14 of an hour isn't 14 minutes because there aren't 100 minutes in an hour. So back to the calculator. 0.14 of an hour is 0.14 times 60, about 8 minutes. Okay, so back to that. So I'm going to just write cycling time. What did I just say? Circa approximately 4 hours and 8 minutes. God, what do they call that rough paper? Something like Klärhefte. I'll just write C yellow paper. No, C yellow hefter. Okay, so we want a graph that shows all of that. So you've got to be careful here because you might see the time on there and think of a travel graph and think of something that goes up and up and up, because the more that the more time they spend, the further they travel. But this is not a time against distance graph, it's a time against speed graph. So their speed is pretty consistently 20 kilometers per hour. The journey is 5 hours 20 minutes, and I already put a marker at 5 hours 20 minutes to show where that is earlier on. And it's a bit irritating actually that this paper is divided into 15s, 15 minutes rather than 20 minutes, but there you go. So it's going to look like they start at 0 speed, they quickly accelerate up to 20 kilometers per hour, then they're consistently 20 kilometers per hour except for a couple of breaks that they take along the way, like that, and then they're going to come to the place and then slowly decelerate to 0 again. So something like that, except the total of the time that they spend cycling should add up to about 4 hours and 8 minutes. So I've kind of got to show all of that. So bit of a horrible question, I think. But I guess you need something to differentiate the top end from everybody else. Okay, so we will start at 0. We will very quickly accelerate up to 20 kilometers per hour. So there's a line showing that. This is tending to snap to nearby values, which is irritating. Let's just move that guy over there a bit. Okay. Then we're going to very consistently be at 20 kilometers per hour. Let's have them doing it for 2 hours there. Then they're going to have a break. So let's have them kind of decelerating down to there, and then taking a break. I mean, I'm not sure this deceleration is going to take 10 minutes as the thing indicates, actually. So I think that the deceleration will take seconds, won't it? So really I ought to have that much sharper there. So maybe more like that. And then that one. Almost vertical. Just move that over there. Okay, so I think I decided they were going to cycle for 4 hours and 8 minutes, didn't I? So let's give them an hour there. Let's give them a little break of, I don't know, half an hour there. And then let's have them accelerating up to 20 again in almost no time. Let's say almost instantaneously. There we go. Then let's have them back at full speed for, or let's say another hour. Before they take another break. Let's have them quickly decelerating down to 0 for that break. So I've got them traveling for 2 hours there, 1 hour there, and then for the very last bit, I guess I want them traveling for another 1 hour and 8 minutes to make the 4 hours and 8 minutes. So let's just have the end of the journey there. So they're going to finish at 0 speed. And well, let's say that 4 of these blocks and that little bit on the end is approximately 1 hour and 8 minutes. So they're going to have a break there. A break there. And cycle there. So 1 hour and 8 minutes. So their cycling time is 4 hours and 8 minutes, and then their break time is going to be 30 minutes there. And well, the whole thing's got to add up to 5 hours and 20 minutes. So for all of that to tally, I guess we want that all to add up to 5 hours and 20. So we've got 2, 3, 4 hours and 8, 4 hours and 38 minutes. Which means, just doing that in my head now, 22, this bit here has got to be 42 minutes. 42 minutes. So I'll just check the whole thing does add up to 5 hours and 20 minutes. So 1, 2, 308, 338, 340, 420. Yeah, happy with that. So I'm just going to take off this line that I did earlier. Oh, I've taken off the whole thing, didn't want to do that. So I'll do another one. There. And then I just think I better mark in 5 hours and 20 minutes, slut, end there. Okay, so that should just about be a perfect answer to the question, with 4 hours and 8 minutes of cycling time, about 72 minutes of break time, and then finishing at 5:20. I reckon most people in the country would get the whole concept of that graph wrong and then just do a sort of increasing thing as if it was time against distance instead of time against speed. But a very tricky question there, in my opinion.